Hello, friends. My name is Derek Harder, and in this video, we're going to be continuing looking at some more details of using the Keras API. So in particular, in this video, we're looking at using the built-in training and evaluation loop that Keras gives you, the fit method, but the various hooks and mechanisms that allow us to get more information and get more use out of the training loop. So in particular, we're going to look at writing your own metrics using callbacks, which can be a very powerful way to help you get more information. Also, we'll take a brief look at the TensorBoard monitoring tool. Okay, so let's go ahead and get started then. Okay, so you're already familiar with the basic workflow that we use with Keras. So compile, fit, evaluate, and then predict, right? So just as a reminder, this is basically how it looks. I'll go ahead and start this running here. So we are going to be using the MNIST again in this notebook for examples. But the basic idea is that, once you create a model, here we're creating a model using the functional API that we talked about previously. You compile a model where you specify your optimizer, the loss function, and any metrics that you want to use during training. You fit your model to your data, possibly giving it explicitly the validation data that you want to use to show you the loss and any metrics you ask for while it's training. And then when you're done, you can use evaluate and predict on a trained model to get information about how it did. Okay. So there are a couple of very useful and common things that we could do in order to make more use out of the basic training loop workflow. We can provide our own metrics that we want to use that are evaluated during training, and we can use callbacks to get hooks into the training loop, so to get more information, or even write our own callbacks. Okay, so let's look first at writing our own metric. So this is just a made-up example. It's actually going to re-implement the root mean squared error. So if you look at what's being done here, just real quickly, that we keep track of our samples and we keep track of a running sum. So the update state is going to be called every time a batch occurs, and we're given this information about the Y true and the Y predictions for the batch. So from that, we're just re-implementing the root mean squared error function. So this is available as a metric in standard Keras. So we take the square of the differences and sum those up. And then if we have to actually get the result, take the square root of taking whatever the running sum is currently divided by the total number of samples we have. All right. So we're hooking this in because so we could have written a completely new metric that you might want to evaluate and use that as a metric. Pass that in as a metric. So we're just, as usual, we're just subclassing from a class that Keras gives us, the keras.metrics.Metric, in order to do this. So as I know, there's actually a bit of a bug here. So I think that we are using, or at least I'm using, much newer versions of TensorFlow than the second edition. The third edition of the book is coming out this year, but it hasn't been posted yet. That's going to be using like TensorFlow 2.19, I believe, or maybe a 2.18 or something. So, but anyway, I do have to run on CPU to get this example to work. But so the basic idea is that we've seen using metrics before. So here we're asking to run it, use the normal accuracy metric, but we also ask it to use our root mean square metric. So you'll see that the things that are being reported are not only the loss and the accuracy, but also the root mean squared error comes out here as a result of using our function, passing that in as a metric in our training loop while we're training our model here. Okay. And I also wanted to mention, in case it's not clear, so that short name comes from the init method. Again, we're overriding that from the base class, so that is why it's referred to RMSE on the output here and the validation RMSE. Okay. Okay, so metrics we may or may not use in this class, our own metrics, but definitely you should be familiar with callbacks. So a callback is an object that's passed to the model in the call to fit, and that gives us hooks so that we can do different things during training while the fit function is working. So at various points. So these are very useful, and we'll see examples and use these a lot. So for example, the most common ones are, so we can have a callback for model checkpointing, right? And so the most common one of this is to have it save the current state of a model, and usually we just have it save only if the model is improved. So we might ask it to give us a checkpoint that keeps track of the best models have been seen so far, like whatever model achieved the best accuracy or whatever model achieved the lowest loss, right? So as it's running, it always saves the best model, and if it sees a better one, it saves that. Or you can have it just save a model at every epoch or every 5 epochs or things like that. Early stopping is very common, so most of when we've seen early stopping so far as examples in this class, we would run a model for more epochs that we need, and then we would just retrain it and stop it at the epoch we determined was where overfitting began. Sometimes that's not practical, so sometimes you've got a model that's going to run for days or weeks or something, even on lots of computational resources. So in that case, you can set up a hook so it will stop running once validation loss has begun increasing for maybe 5 epochs in a row, or you can have different criteria for early stopping. And there's others, so I don't know if we'll see an example of this, but sometimes better than the advanced optimizers how learning rate should be tweaked. So you can, for example, tweak learning rate while things are running, and there's things for other kinds of callbacks. So of those, the two that might be the most useful are the early stopping and the model checkpoint. So let's look at an example of using those. Okay, so to use callbacks in the fitness function, all we have to do is pass in a list of the callbacks that we want to use. Okay, so in this example, we're just creating a list, and in that list, we're going to pass it in 2 callbacks. So the first one is an example of using the early stopping. So basically what this is saying is that stop, as soon as the validation accuracy that we're monitoring here, as soon as it goes for 2 epochs where validation accuracy is increased twice in a row. Okay, so we'll stop early once validation accuracy goes up for 2 epochs in a row. Okay, so in order for this to work, we have to have accuracy as a metric that we're monitoring during our training loop, right? So that has to be one of the metrics that we pass into the compiling. And also, so we'll show an example of using the model checkpoint to keep the best model that we've seen so far. Although, again, we could have had it keep the best model that achieves the best validation accuracy, but here we have it keep the best model, the one that achieves the lowest validation loss that we see while we're running. In this case, we're going to save the models to a subdirectory in our project in the models, and we're going to have it call it this name. Okay? So let's go ahead and start running our example here where we're going to be using the callbacks. So I'll let it run a while here. So notice that we started out to run for 20 epochs. Okay, so the first thing we should check for is whether the early stopping happens, right? So what should usually happen is, since we said that it's monitoring validation accuracy, and it should have a patience that if validation accuracy, once it goes up, gets bigger for 2 epochs in a row, that's when it should go ahead and stop the model. So usually it takes around 10 epochs or so before that happens, but we can kind of monitor it here. So, validation accuracy has gone to 0.09, went up a little bit, but it went back down, so it decided to keep going here, 0.981, and so on. The other thing is that we are keeping a checkpoint by watching the validation loss, right? So whatever the best validation loss that we see is the one it should keep, right? So far, I was looking at validation loss here. So validation accuracy so far is going down. Since we're monitoring validation accuracy, we're trying to maximize that. So I kind of had that reversed. For these basic ones, Keras does know whether it's a maximization or minimization it's trying to do. So for accuracy, we want higher is better. So here, if it went down twice in a row, so it's been going up, reached a peak of 0.98 for the accuracy, and then we saw it go down, and then it went up a little bit, but it was still down from the highest that it ever had. So early stopping kicked in, and that's why it stopped right there at that epoch. All right. And then the other one where we're doing the checkpoints, it should have been doing the checkpoint for the model that had the lowest loss, since we're trying to minimize loss. So in that case, if we were to check it, it should have ended up saving the weights here that just happened to correspond to the one that had the highest accuracy. So the one with 0.883 here. So we can check that we did get that model. And there would have been ways that I probably should have gone there. There would have been ways to check which epoch it was saved from. But in this case, if we go and look in our repository under our model subdirectory, we do see now that there's a examples best model. So that has basically saved all the weights for all the layers of our model here, as it was when it had the lowest loss where we're running it here. You can save and reload models as you want, right? So this is another useful thing to know about these. So if I wanted to save the final model that I had, I could do a model save, and you can give it any path that you want to and any name, although you do need to use the .keras file extension when you do those. So now I've got two versions of my models saved in my model subdirectory, the best one and the final model that we had. And if we wanted to, we could reload the best model, and I could probably figure out what epoch it stopped at and look at all the weights and do evaluations or whatever we wanted to with it at this point. You can also write your own callbacks, which we might need in this course. So similar to writing your own metric, if you need to subclass the callback class from Keras. So this gives you an idea of kind of the hooks that you're getting from these callbacks. So at the beginning or ending of each epoch, or within an epoch. So if we're doing mini batch training, there'll be multiple batches that make up an epoch. So at the beginning or end of each batch, you can have a call, or at the very start or very end of training, you can have a callback do something for you. So, and there might be some others. I'm not certain if that's an exhaustive list of all the hooks that you have. So just real quickly, if we needed to monitor something after the end of every batch, that's what this example, our own writing of our own callback is doing here. So at the end of every, batch of training, we're going to append our losses so that we can have a per batch measurement of our loss here. Okay? And at the end of the epoch, we're going to actually create a figure. So we're actually doing two hooks in this callback here. So after every batch, we keep a list of our losses, and then at the end of every epoch, we actually generate a figure, and we save it after a figure subdirectory. Okay. Let's just go ahead and run that. So I'll just let that run. But this is from running it before. You can see what the loss looked like. Actually, this was the loss from the first epoch that we're displaying. So with training finished here, we can see that the last figure that's generated actually gets shown on the output inside of your notebook here. So that was actually the loss for each batch on the last epoch. So note that the fit function labels these one starting at index 1, so there's 1 through 10, but they're numbered 0 through 9 internally if you're doing these kind of callbacks. And if we look at our repository's figures, we should see that it actually did save those figures, plot epoch 0 through 9 out there where we asked it to. So those callbacks were getting called and generating those figures there to do stuff. Okay, and finally, just a quick demonstration of using TensorBoard. So TensorBoard is a browser-based application that you can run locally. So it's like the Jupyter Lab server. So it runs as a web server, opens up a port. So you have to use your normal browser to navigate and open up while TensorBoard is running. Okay, so it basically monitors the log directory. So when you specify if you want to use the TensorBoard, you have to pass that as a callback for your fit method. You specify the directory where to put the logs, and then you have to start off your TensorBoard to actually monitor that log directory. Okay, so let's try this out. So a couple of things. I'm going to show this specifically for using this if you're using the DevContainer environment. Like you're supposed to be using for my class here. So actually I'm going to go ahead and start this off first here. So if you're running TensorBoard inside of a dev container, you do need to use this bind all. If you're just running it on your own host system, not inside of a container, I don't think the bind all is necessary. And if you want to get interactive updates without having to do a reload or refresh, I think this parameters works now. So I'll just copy that. So what I normally do is I open, I go to my my running VS Code running inside of a dev container, and I open up a terminal. So right now there's no logs directory. So where I'm running my notebook, it's running up inside of the notebooks subdirectory. From here, right? So all my notebooks are right here. So when we specify, if I go back and look at that, so when we run this for the callback, we're saying that it should put its logs one up into a subdirectory called logs, and that doesn't exist yet. Okay, so I'll go ahead and start the TensorBoard first, right? So here we're going to be running this. This is going to be running as a server. And you'll see that it actually runs by default on port 6006. So where's the URL here? Right there. So so that's really kind of the machine name, but the port number is 6006, but it's running inside the container. Okay, so to see that port, you do have to have that port open, right? So you can actually add that port by hand. So it gets forwarded to your host system, or I usually in the DevContainer.json file is where you can list the port, so you can add that as a port every time you restart your dev container to be open up and being served to your local host. So now that I've got something running on that, I can control click on that. We can see now the TensorBoard is running. So the same as like running the Jupyter Hub server, the Jupyter Lab server. My TensorBoard is now running, but I'm not actually running my training loop, so I don't have that logs subdirectory, so I can't find anything yet. So let's go ahead and try starting it off right now. So so by doing this, so by running fit here using this callback, it should be putting data into my logs subdirectory. Okay, so if I was to open up another terminal here, I should now see that I've got a log subdirectory that was created while we were running that. So if we go back and look at TensorBoard, I was hoping that would automatically update here. So yeah, I don't know if that reload is working automatically. I'll have to check with that again. So, if that's not working, maybe it's a different parameter. Maybe I said to do it every 2 minutes and I meant like every 2 seconds or something. So you can see it is actually getting the data. So we're showing accuracy. So this is the same as the training curves. So any metric you specify, you can see on here. So we can see the accuracy. We can see the loss as it's occurring over each epoch and so on. I think there's ways to combine these to get these on the same graph or other stuff like that. I think there is a way now to actually have it automatically update here instead of having to refresh by hand. So far, we are done with all 10 epochs here. So one more refresh, I should see everything. Yeah, so there's epochs. They're numbered 0 through 9 instead of 1 through 10 here, but the same idea. So here was our accuracy on the black is the training data, and the blue is accuracy on the validation data. And here was our loss on training and validation data here. Okay. Okay, anyway, so that was a quick look at TensorBoard. It is useful if you're running, when you get into doing serious stuff and your runs are going to take hours or days. So, you can monitor that, and if things go off the rails, you can stop and recalibrate and restart something that'll be more productive instead of letting a useless run continue on and taking up your compute resources. So. Okay, so to summarize, just a couple of things that we've looked at in this video. So Keras provides you a standard workflow for building a model, compiling it, fitting the model, and then doing predictions and evaluating the model. So if you're doing something out of the ordinary, you can subclass the metric class, or you can subclass the callback class to add in your own metrics and callbacks. But especially, you should be aware of callbacks. So those are useful. We'll use those a lot. So for doing model checkpointing, early stopping, and other use cases, callbacks will give you better control, better visibility into your training loop as it's happening. TensorBoard can be a useful tool, so you might want to learn how to use that and be able to access it so that you can use that to monitor your runs as they are training. Okay. So that's it for this video. I hope that was useful for you, and I hope you join me in the next video.